All right, so today we're going to take a deep dive into some interesting territory.
Okay.
Rust's asynchronous functions.
Hmm.
You sent over a blog post and it really detailed a pretty common error message
Yeah,
that tends to trip up a lot of Rust newcomers.
right.
Specifically, error E0752. Main function is not allowed to be async.
Oh, yeah, I've seen that one.
Yeah, and we're going to unpack what this means and why it even
It's
happens.
a hurdle I think almost everyone encounters when they first start working with async in Rust.
Yeah.
It's like the language is telling you, hold on, we need to do things a little differently here.
Exactly. And this blog post actually follows the journey of Aang.
Oh,
He's a programmer who's making the leap from Python to Rust for CLI development.
interesting.
What I found really fascinating is that he's taking such a hands-on approach to learning.
Uh-huh.
He's using personal projects and even AI chatbots
Wow.
to just make sense of things.
That's becoming increasingly common, I think. Having those tools readily available can really help to demystify some of the complexities,
Right.
especially when you're starting out.
Absolutely. But before we get too deep into the tools,
Okay.
let's talk about this error message.
All right.
Error E0752.
Okay.
Main function is not allowed to be async.
Right.
So Aang tried to make his main function asynchronous, which, seems logical on the surface.
Yeah,
But Rust just throws up a roadblock.
it does.
Why is that?
Well, it all boils down to how Rust programs interact with the operating system.
Okay.
Think of the main function as the entry point,
Okay.
the very first thing that gets executed.
Right.
The operating system expects this entry point to be synchronous,
Got it.
like a clear handshake to kick things off.
So it's a bit like following protocol.
Yes.
The operating system needs things to happen in a specific order,
Exactly.
and an asynchronous main function just disrupts that flow.
Precisely. An asynchronous function implies that things might happen out of order or
Yeah.
concurrently. And that just doesn't play well with the operating system's expectations.
Yeah. For that initial startup phase,
Right.
that makes a lot of sense. It has to be reliable and predictable.
It does.
But how do we get around this if we want to use asynchronous functions in our programs?
That's where asynchronous runtime libraries come in.
Okay.
They act as intermediaries, allowing you to run your asynchronous code
Yeah.
within that synchronous main function environment.
Okay.
Aang explored two of the most popular options,
Yeah.
Tokio and async.
Perfect. Let's dive into those, starting with Tokio.
Okay.
We know it's often seen as the more robust and mature option,
Yeah, it is.
favored for its extensive library support and performance, especially for network-intensive applications.
Right.
But I'm guessing there's a bit of setup involved.
Yeah, there are a few things you need to do.
Yeah.
Aang had to add Tokio as a dependency
Right.
and enable a couple of features,
Okay.
macros and multi-thread.
Mm.
And then there's the use of the hashtag Tokio.main macro, which essentially lets Tokio manage the asynchronous execution within the main function.
So for those unfamiliar with macros, could you quickly explain what they are
Sure.
and why they're important here?
Essentially, macros are a way to extend the Rust language.
Okay.
It provides a way to generate code at compile time.
Uh-huh.
Think of them as a shortcut for writing repetitive code or creating new syntax.
Right.
In this case, the hashtag Tokio.main macro transforms the main function,
Okay.
allowing it to work seamlessly with the Tokio runtime.
Got it. So it's like Tokio sets up the stage behind the scenes,
Yes.
making it possible for that asynchronous code to run smoothly
Right.
within that synchronous main function.
Exactly.
Now, what about async synced?
Okay.
How does it compare?
Async is often lauded for its simplicity.
Okay.
Its API is designed to be more beginner-friendly,
Uh-huh.
making it a great option for those just starting out with asynchronous programming in Rust.
Got it.
Similar to Tokio, you need to add it as a dependency
Right.
and enable the attributes feature. Then you can use the hashtag asynctd.main macro,
Mm-hmm.
which is conceptually very similar to Tokio's approach.
It's interesting that even at this early stage, Aang's already peeking under the hood
Yeah.
and comparing the code of these libraries.
He
You mentioned that async Solid's code seemed less complex.
That could be a real confidence booster for someone starting out.
Yeah.
Sometimes seeing a simpler implementation can make the concepts click more easily.
For sure.
But it's also important to remember that choosing the right library is all about context.
Right.
Tokio's power and performance are ideal for demanding applications.
Yeah.
Async with its user-friendliness could be perfect for smaller projects.
So it's like choosing the right tool for the job.
Exactly.
A sturdy workhorse versus a nimble racer.
I like that.
But both can get you to the finish line in their own way.
They can.
I'm curious, though.
Yeah.
You mentioned this idea of a runtime.
Yes.
Can you elaborate on what an asynchronous runtime actually does behind the scenes?
Sure.
What kind of magic is happening there?
Well, it's a bit like a well-choreographed dance.
Yeah.
Imagine you have a bunch of tasks that need to be done.
Okay.
Some are quick, some might involve waiting for something else to finish.
Mm-hmm.
In a synchronous world, you do these tasks one after the other,
Yeah.
waiting for each one to fully complete before moving on.
Right.
But with an asynchronous runtime, you have this elegant system for managing these tasks concurrently,
Okay.
making the most of the available resources.
Okay. I'm starting to visualize it.
Good.
But how does it actually work in practice?
Yeah.
What's going on behind the curtain?
At the heart of it is something called an event loop.
Okay.
Think of it as the conductor of the orchestra, keeping everything in sync.
Right.
The event loop constantly checks for events,
Okay.
like a completed network request or a finished file operation.
So instead of the program just sitting there idly waiting,
Yes.
the event loop is actively checking for updates and making
Mhm.
sure things keep moving.
Exactly. And when an event occurs, the runtime knows which part of the code needs to be triggered next.
Okay.
It picks up that task and executes it,
Got it.
all while the main thread can continue doing other work.
That's pretty clever.
It is.
So we're not really running things in parallel in the true sense,
Right.
but it's more like this intricate system of task switching,
Yeah.
giving the illusion of things happening simultaneously.
It's a powerful technique for dealing with operations that might involve waiting,
Okay.
allowing the program to remain responsive and efficient.
It's like having a team of skilled chefs in a restaurant kitchen.
Okay.
While one chef is waiting for the pasta to boil,
Yeah.
they can start chopping vegetables for another dish.
Uh-huh.
It keeps the whole operation flowing smoothly.
That's a fantastic analogy, and it highlights the key benefit: efficiency.
Okay.
Asynchronous programming really shines when you have tasks that could potentially block execution,
Mm-hmm.
like network requests.
Yeah.
With a runtime, you can initiate those requests and move on to other tasks
Okay.
while you wait for the response.
So the program doesn't get stuck waiting for that slow network request to finish.
Exactly.
It can keep doing other things in the meantime.
It can.
It's like multitasking for code.
Yes, it is.
This is really starting to make sense.
Good.
It's all about optimizing resource utilization.
It is.
And this becomes crucial when you're building applications that need to handle many concurrent operations,
Right.
like a web server processing multiple client requests at the same time.
Exactly.
That makes a lot of sense. Now let's go back to Tokio and async for a moment.
Okay.
You mentioned earlier that choosing the right tool is important.
Yeah.
Can you elaborate on the key differences between these two runtimes?
Sure.
What are the factors I should consider when making that decision?
Great question, as we touched upon earlier.
Yeah.
Tokio is often the go-to choice for performance-critical applications,
Okay.
especially those heavily reliant on networking.
Mm-hmm.
It's been battle-tested in large-scale production environments and has a vast ecosystem of supporting libraries.
So if I'm building a high-performance web server that needs to handle thousands of concurrent connections,
Right.
Tokio would be the way to go.
Absolutely. Its focus on speed and efficiency makes it ideal for those scenarios.
Okay.
Async, on the other hand, prioritizes simplicity and ease of use.
Uh-huh.
Its API is more streamlined, which can be less daunting for newcomers to the asynchronous world of Rust.
So for smaller projects or for someone just starting out with asynchronous programming,
Yeah.
async might be the better entry point.
Exactly. It allows you to focus on learning the core concepts
Right.
without getting bogged down by the complexities of a more feature-rich runtime like Tokio.
Got it.
Think of it as choosing between a powerful sports car and a reliable family sedan.
Okay.
Both can get you where you need to go, but they cater to different needs and preferences.
This is really helpful in understanding the landscape of options.
Good.
But what I find fascinating is that both of these approaches solve the same fundamental problem, that need to reconcile asynchronous code with Rust's requirement for a synchronous main function.
Yeah.
It's like they found different paths to the same destination.
It speaks to the ingenuity of the Rust community
Ah,
and the flexibility of the language itself.
yeah.
And it's a testament to the idea that there's often more than one way to solve a problem in programming.
Mm-hmm.
It's about finding the approach that best aligns with your specific needs and priorities.
I'm curious, though.
Yeah.
Are there any trade-offs to using these runtimes?
Uh-huh.
Is there a performance cost, or are there any potential downsides we should be aware of?
That's an insightful question. While runtimes provide this elegant solution for integrating asynchronous code,
Right.
There was a slight overhead associated with managing tasks and switching between them.
So it's not entirely free.
Right.
There's a small price to pay for that asynchronous magic.
Precisely. But in most cases, the benefits of asynchronous programming far outweigh this minor overhead.
Yeah.
Increased efficiency, responsiveness,
Yeah.
and the ability to handle concurrency. It's like investing a little bit of effort up front to reap significant rewards down the line.
Exactly. And that's why asynchronous programming has become so prevalent in modern software development,
Oh, yeah.
especially when building applications that need to be highly performant and responsive.
Right. It has, yeah.
This has been such an illuminating dive into the world of asynchronous programming in Rust.
It has been.
We've explored the reasons behind the error message that sparked this whole discussion.
Mm-hmm.
We delved into the workings of asynchronous runtimes
Yeah,
and even got a glimpse into the nuances of choosing between Tokio and async.
we did.
It's amazing to think about all the intricate mechanisms working behind the scenes
It is.
to make asynchronous programming possible.
It truly is a testament to the ingenuity of the developers who created these runtime libraries.
And speaking of ingenuity,
Yeah.
I have to give Aang credit for not only diving into Rust, but also embracing the help of AI chatbots
Right.
to understand the code. It's like having a coding buddy available 24/7 to answer your questions and clarify those head-scratching moments.
His use of AI to break down complex syntax highlights a really interesting trend
Yeah.
in how developers are learning and problem solving.
Mm-hmm.
This accessibility of knowledge is empowering for both new and experienced programmers.
Imagine being able to instantly get an explanation for that obscure error message
Right.
or decipher a particularly cryptic piece of code.
Yeah.
It could significantly accelerate the learning process.
It could.
Or make exploring new technologies less daunting.
It makes you wonder how these AI-powered tools will continue to shape the future of programming.
Right.
Will we see even more integration of AI into our development workflows?
Yeah.
Will it fundamentally change how we approach software development?
It's exciting to think about the possibilities.
It is.
But for now, let's bring it back to Aang's journey with Rust.
Okay.
He's already overcome that initial hurdle of the asynchronous main function
Right.
and discovered the power of runtime libraries like Tokio and async.
He has.
He even started to explore the nuances of Rust's syntax
Yeah.
with the help of AI.
It's a great reminder that learning a new programming language is a journey.
It is.
And every step, even the mistakes, is part of the process.
So what does this all mean for you?
Yep.
If you're intrigued by Rust and the world of systems programming, don't be afraid to dive in.
I agree.
Embrace the challenges, experiment with different libraries, and don't hesitate to seek help when you need it.
Right.
Who knows, maybe you'll discover a passion for building the next generation of high-performance,
Yeah.
concurrent applications.
The world of Rust is full of possibilities, and we encourage you to explore it.
This has been such a rewarding deep dive into the intricacies of asynchronous programming in Rust.
It has.
We've uncovered the reasons behind that cryptic error message,
Mm-hmm.
explored the roles of Tokio and async,
Yeah.
and even touched upon the evolving landscape of learning with AI.
We did.
And of course, it wouldn't be a complete deep dive without acknowledging the unsung heroes. The developers who create these amazing tools and libraries that make all of this possible.
Yeah.
Their ingenuity and dedication are what drive innovation in the world of programming.
Well said. It's been a pleasure unraveling these technical mysteries with you.
As always, the journey of exploration is just as important as the destination.
It is.
And in the ever-evolving world of software development, there's always something new to learn, some new challenge to tackle.
There is.
So keep that curiosity alive,
Yes.
keep experimenting,
Uh-huh.
and keep pushing the boundaries of what's possible.
Until next time.